Good morning. In this video, we are talking about access to clean water, a sustainable, scalable, and easily accessible solution to guarantee equal and just consumption in some with non-potable water sources. We are civil engineering students. I am Joaquín Borghello.
I am Irina Velasquez.
And I am Bustamante. We are a student at National Tecnológica University from Paraná Regional Faculty.
Now, I am going to talk about a local frame. Then Sol is going to present a global frame. And finally, Irina is going to present the map of this presentation. So, around the world, the water crisis is a reality that affects the most marginal areas, causing diverse and large problems. Those issues mainly affect women and children, resulting in health and economic problems, school dropout, and even death. There are some small towns located near non-drinking water courses, but do not have the necessary infrastructure to purify water. Some inhabitants drink from polluted streams and rivers. For example, this is the situation in Oman, a country in Western Asia. This situation is so commonplace that they seem to be the norm. However, it is important to disrupt the status quo and look for a solution that the inhabitants of that place deserve.
According to National Academy of Engineering, household water is usually account for less than 5% of total water use. Although it is a small number, this represents a big problem in the world. This issue is directly addressed by the Sustainable Development Goals 23 agenda, more specifically by means of its goal number 6, ensure access to water and sanitation for all. There are some initiatives to improve this issue by providing different solutions, but not all the solutions are viable for the affected area due to the high cost that would result in energy consumption and maintenance.
This paper will address solution to drinking water of accessibility that include the use renewable energy to guarantee equal and just consumption of water in a sustainable and scalable way. To achieve this objective, this article is developed as follows. First, the current global water issue will be presented. Second, the HELIO system and the way it works will be introduced. Third, is brief explanation of some different projects, similar different projects. And finally, HELIO system will be compared with the other project.
Now, I am going to present the water issue. At the present, 771 million people lack access to safe drinking water. According to a report by the World Economic Forum, the water crisis is the 5th global risk in terms to impact to society.
The lack of drinking water is responsible for more deaths in the world than war. In the sense, each day nearly 5,000 children worldwide die from diarrhea-related diseases. Approximately 1 in 6 people living today do not have adequate access to water, and more than twice that number lack basic sanitation. For this reason, the water is needed.
However, the problem is not that there is not enough water. Although globally water is available in abundance, it is not always located where it is needed or there is not the necessary infrastructure to carry.
Now I am going to present the HELIO system. In areas where there are water sources but it is not drinkable, it is important to have a system that purifies and stores the water so that the inhabitants of that place can have access to this vital service. Based on this idea, a French company called Marine Tech has developed a product that satisfies the need in addition to using clean energy. This system helps low or medium income areas, science cities, easy economic access, easy to obtain the water needed, and has an average useful life of 30 years. HELIO has a capacity for a family of 5 people or even for a group of 25 people.
Now, Irina and me, we are going to talk about the HELIO system operation. This system is a plastic affair where installation occurs through the following process system. In the first place, the water is captured directly from the source, which can be seas, lakes, rivers, or any basin that does not have drinking water. To capture it, a water pump powered by a solar panel is used, which is a clean energy source. In the second place, the water is stored in containers inside the regulator major. The smallest container has the fluid valve system that controls the overflow of water into the largest containers. From here, by the action of gravity and the pressure work, the water is propelled through a system of pipes towards the sphere. There, it reaches a metal tray, forming a film of water, which will evaporate.
Then the water in the sphere begins to evaporate due to its direct contact with the sun's rays, which increase the internal temperature of the sphere. The water vapor condenses on the inner walls of the sphere and by means of gravity, it accumulates at the bottom of the sphere. In this way, the high internal temperature, which is produced by the action of the sun reflects on a plate under the sphere, eliminates germs and bacteria from the stored water. Finally, by means of a pipe and faucet, the water can be withdrawn directly for consumption. I will present the HELIO system component. The system is made up of the regulator module and the sphere where the distillation takes place. Both parts are connected by means of a pipe system. Now, Joaquín and Sol are going to describe this component.
The regulator module is the central part of the system, in charge of regulating and distributing the contaminated water. The semi-sphere-shaped plastic module is supported by a removable aluminum structure. Inside it, there are 2 containers of the same material. The smallest container is the one that receives the contaminated water from the pump and have the fluid bag. And the largest container is the one that, due to overflow, is filled and distributes the contaminated water through a plastic pipe system. Finally, the aforementioned pump works with a small solar panel about 0.25 square meters.
The distillation methods are plastic affairs with a surface area of 1 square meter. Inside, they contain an aluminum tray connected to a pipe that comes from the regulator modules and allows the film of water to fall on the surface of the tray. Under the sphere, there is a polished stainless steel plate which is similar to a mirror that allows the reflection of sunlight and then the reverberation. These components are supported by a renewable aluminum structure that thus leaving a system of 1.18 to 1.2.10 meters with 18 kilograms.
Now, I will present the similar water purification project. As the scarcity of drinking water is a global problem, it is well known that there are various possibilities to reduce it. In this section, other alternatives in development will be presented. The first project is vapor condensation with daytime reactive coil. This project was developed by a time that with a small vapor condenser based on the biological system of the dark beetle found in the Namib Desert in southwestern Africa. Using a thin film of material called polydimethylsiloxane. This material is very efficient in releasing thermal radiation in the atmospheric transparency window and is therefore placed on silver to reflect sunlight. This combination makes the condenser cool below the dew point of time its condensation. The reactive condenser is thought to be in thermal contact with the cold reservoir in the upper atmosphere and in outer space with the cooling power condensing water during the day without the need for an external power supply. To clarify, the system produces its own clean water without cold contaminated water.
The second project is about solar water purification with photocatalytic nanocomposite filter based on titanium dioxide nanowires and carbon nanotubes. This project addresses the access to clean and safe drinking water in electricity poor regions, where the advanced water purification methods are absent. In those places, it has been shown that titanium dioxide nanowire filters, assisted only with sunlight, can efficiently decontaminate the water by producing of reactive oxygen species. Also, interviewing this filter with carbon nanotubes offers an additional water decontamination channel, which is pasteurization. These filters can intercept various types of microbial pathogens, including bacteria and large viruses. So also contributes to an efficient removal of a lot of organic compounds and infected microbes. The device has a very simple configuration. The contaminated water is stored in a tank, then passes through a multi-layered filter material, and the pathogens are trapped on the filter surface, while the UV component of the sunlight produces reactive oxygen species, and thus provides decontamination. And finally, the carbon nanotubes absorb a broad range of the solar radiation, which heats up the filter material and thus provide pasteurization.
The third project is soil microbial fusing. The soil is naturally rich in microorganisms, and this allows it to harvest to its own energy, which is why some microorganisms have the ability to transfer electrons through their cell membranes to conductive materials, such as electrode, which is result in generation of electrons. This system consists of an array of soil microbial fusing SMFC that powers an electrochemical reactor for water treatment. Each SMFC is characterized by a fluid geometry and consists of two carbon-based electrodes positioned at 4 cm apart and connected to an external circuit. One electrode, the anode, is buried inside the soils, with the other, the cathode, is exposed to air on the soil surface. The molecules that emit electrons, known as electrons, consume the organic compound to generate charged particles. These electrons are transferred to anode and travel to the cathode via the external circuit, producing electricity.
Now, I will present the comparison of the different systems proposed in order to demonstrate the advantage of the HELIO system in terms of water collection, system operation, component, material, capacity, assembly. It will be compared with the different projects previously presented. In this way, we do this through a comparative table. In terms of contaminated water collection method, HELIO system use a solar water pump to collect contaminated water. Project A and Project C do not collect contaminated water, and Project B uses a water tank to store contaminated water.
In terms of system operation, the HELIO system and Project A uses evaporation and condensation by solar radiation. The Project B uses solar radiation pasteurization, and Project C uses indirect purification. In terms of component material, the HELIO system uses plastic sphere with aluminum structure. The Project A uses silver film and PDMS. The Project B uses titanium dioxide nanowise filter and carbon nanotube, and the Project C uses soil microbial fusing.
In terms of capacity, HELIO system is for medium and large scales, and the rest of the project are from small scales. And finally, in terms of assembly, HELIO system does not need experts. The projects A and C need experts, and the project B does not need experts. In this manner, it is demonstrated that HELIO is the best alternative to water purification because of the great adaptation to the environment where it is installed, easy and speed of assembly, and the great results in the short time.
Well, in conclusion, this work delves into one of the most urgent problems worldwide, which is the lack of drinking water. Although there is a large amount of water, its use is limited. Science that are bases that have the capacity to purify contaminated water but do not have the source, and others where they have the resources but do not have the economic capacity required to make the water drinkable. The lack of these necessary resources to lead to different diseases and adverse conditions for the correct development of life, mainly during childhood.
Based on a comparison made with different systems. The HELIO system is proposed as the best alternative to address the lack of clean water issue, without much infrastructure required. This system does not consume conventional energy and is sustained by solar energy, producing approximately a total of 10 liters per day, designated for a family of 5 people. However, a system series installation can be built that result in increased liters of purified water per day. The conclusion obtained in this work allows us to affirm the HELIO is one of systems that help low or medium income areas, since it is of easy economic access, easy to obtain the water needed, and has an average useful life of 30 years.
Finally, it is mainly important to be aware of the fact that more work and commitment are needed to reverse this problem. It is essential to guarantee each and every inhabitant of this planet the access to safe water with sustainable, scalable, and easy accessible solution to ensure just and equal consumption. Thank you for your attention. We appreciate it.